All right, it's Jeffrey here again. What color should we use? Orange. Big data and applications is the course, or X informatics is the old name, which has fallen into disuse. And we're doing the Internet of Things and Sensors, unit and section. And we're doing a second lesson on the Industrial Internet of Things. And here I am, and off we go. So we're on lesson 4 in this unit, and we're doing some examples from General Electric, who are a real pioneer in this area. I'm really impressed by their effort in the Internet of Things. So these are just examples from their GE software site. Remember, they have this software division in Silicon Valley with 700 people, grown in the last 3 years. And here is just illustrating one particular part of their work: wind farms, all these rotating vanes. And you have here control systems, which is this, and analytics, deciding what the presumably optimal speed to rotate given the wind and things like that, and what the power demands and the ease of storing it and things. Here's our control room here, but presumably most of this is computer controlled. So we have here they show various sensors on the engine and on the vanes, presumably. And this is just one example of the IIoT applied to power generation. Here is a more general example of the old style way that things were done in the engine world. Then you have engines which break, and then you have costs because your machines break. And you have servers which are sitting in all over the place, and the servers have the wrong software in them, and the machines have the wrong software in them, and then you have networks that are rather flaky, and you find you can't deploy your nifty new software and things like that. So that's yesterday's half-hearted attempt at automation. And here we have the new thing, with everything fully interconnected in a reliable fashion, presumably wireless networking, clouds, and a robust environment, maybe on some, sort of what you might call local proxies to do the computations that need to be done in a time-sensitive fashion. We have, just as we have this application ecosystem for smartphones, we have an application ecosystem for machines, and every machine can download its version of Minecraft and build itself a simulation of itself or something like that. And when they get and then I don't know whether machines will unfortunately become so intelligent. They will want other more frivolous applications, but at least they'll be able to download the applications to monitor their health and tell them what to do better to survive longer with less fuel. There's a very pretty site at this Rail Connect 360 URL where you can press buttons and all sorts of nifty things happen. Here is some sort of rail transportation center, and these trains here all move around. And if you press these knobs, you get various informations from sensors. And well, very nicely done site. I'm not quite certain it just looks pretty. I'm not quite certain actually gain an awful lot of information from this site, except I'm impressed that they would put so much effort into it. All right, here we have an example of one of the things you can do. Here you can actually make the trains move, and then you can put up little vignettes that you can save $2.5 billion a year in crew, fuel, and asset costs by doing a better velocity optimization. And that comes from here. You see here you have these tabs here. You can look at the various fuel efficiency tab and things like that. So this is the final slide of this set with this really nice idea of a software-defined machine. Of course, I like that because we have software-defined networks, software-defined computer systems. Here we have software-defined machines. And they involve the linkage of the clouds to the machine. Some of the software's on the machine, some of the software's on the cloud, and the whole application links them together. That's the challenge. To link clouds to machines, machines to machines, that's orchestration or systems. So just as you have computer systems built using, what is it, OpenStack heat. So I don't know, we're not going to run fully OpenStack on every one of our machines, but we might run, I don't know, Docker on every one of our machines, the equivalent of Docker. And then we would then link all these things together with the equivalent of Apache Crunch to integrate them together to produce this wonderful software-defined machine, which was going to do whatever we wanted to do at less cost in some optimal fashion that also runs in a more conservative way that makes all the machines last longer. So that's it. Software-defined machines and software-defined railroads and software-defined wind farms. That's what we've seen in this lesson. It's a pretty interesting future. Thank you very much.